Number one on the quiz can be worked in several ways. What most people do is they take $800 and they multiply it by the tax rate 0.075 and get 60. Then they add 800 and they get 860, which is absolutely perfectly correct. That is the usual way. The cool way, and here's kind of the new thing that I want you all to get. If you take a number like 800 and you increase it by 7.5% of it, you wind up with 100% of 800 plus 7.5% of 800. And that is 800 times 107.5% changed to a decimal, which is 1.075. And you get to 860 right away. The advantage of that is there are other kinds of problems that I've given you, such as number 2, in which, like, suppose the 860 was the price including tax and you didn't know the 800. All you know is that if you take the selling price and you add 7.5% of it to it, you get 860. To get back to that, you cannot get there multiplying 860 by 0.075. You have to actually divide it by 1.075. That gets you back to the 800. So for example, in number 2, the donuts are $6.75 a dozen, tax included. The tax rate is 7.75%. How much is tax and how much goes for the donut? I have asked you 2 problems. You got to do 2 problems then. So for number 2, you can do it with algebra, or you can do it with just arithmetic reasoning. You don't know the price of the donuts before tax. So you can't calculate the tax by multiplying $6.75. The tax is already in there. If you multiply that by 0.0775, it's not the tax. That would be the tax if the before tax price were $6.75. So what you have to know seriously is, I don't know what it was before tax, but if I multiply that number by 7.75% changed to a decimal, I get 107.75% of the money. So the calculation to undo that is 6.75 divided by 1.0775. And don't forget there's 2 sevens. You got to look at the numbers really carefully. So that turns out to be 6.2645. To the nearest penny, it's 6.26 because the 4 is not big enough to jump it up to 6.27. And you do not do it this, don't say, well, the 5 changes the 4 to a 5, and then it's a 5, and then it's 627. No, it's the single digit to the right of the pennies must be 5 or more in order to increase it. Now, the way you can figure out what the tax was without clearing it, you can just say minus the $6.75. It's going to be kind of ugly, but that's all right. It's going to be negative. You got subtracted it backwards. I can change that sign with my plus minus button. So the tax is $0.485, and that's 49 cents, or $0.49. I put the 0 there to call your attention to it. And it's not 627. Okay. Number 3, most of the answers I saw for number 3 were not correct. Number 3 is, you don't know what to sell it for, so that after you give the agent the selling the car on consignment, after you give the agent 15% of the selling price. And that's not 15% of what Dr. Lemon wants to get back afterwards. She's going to get the other 85%. So just like when you increase a number by 7.5% of itself, you wind up with 107.5% of a number. If you decrease a number by 15% of itself, you wind up with 85% of itself. And the trouble is, not trouble, the good news is, you know what that 85% is supposed to be. It's 44,800. And that needs to be the other 85%. So I got to divide that by 0.85. And I get $52,705.88. Whoa. To the nearest penny. I'm going to write that down here. $52,705.88. Now, to show you how that can be checked, you can do it one or two ways. 52,705.88. You can multiply it by 0.15, and that gives you $7,905. $7,905, and to the nearest penny, 88 cents. And when you subtract that from 52,705 and 88 cents, you get, guess what? $44,799.998. In this case, the nearest penny, the 8 is big enough to make this 99 cents the next full dollar. So rounded off, it's 44,800, which is exactly what it's supposed to be. A little tricky. Number 4, the 17,000. What I want to call your attention to on number 4 is that it's exactly like number 9 on page 5. Exactly, but with different numbers. So where did I work out number 9? Well, I worked it out here with the formula, which is the out the door price minus the tax, minus the fees divided by 1 point the tax rate, and then that divided by the part that's not discounted. It was 15% off, it's 85% on. So for this problem, number 4, you would take $17,450 and subtract the fees, $488.60. You don't have to put the 0, but you can if you want to. Hit the equal sign. Then you have to divide that by 1 point the tax, and the tax is 8%, that's 0.08. And then you have to divide that by the percent that was not discounted. If it's 10% off, it's 90% not off, which is 0.9. And you get $17,450. A few of you got all 4 of these right. Almost everybody missed at least one of them. And my goal is for all of you to get 100 on the percent test in 9 days. All right. There's a couple of problems, well, more than a couple. There's a few problems on the, what do we have, page 9 and 10, that we hadn't seen before. And you've seen 1, and you've seen 2, and you've seen the percent increase, and you've seen the deposit. And a lot of these are very similar. It's kind of like number 4, you're adding interest to whatever you deposit. And sometimes you know the answer to that. In this case, number 6, for example, you're adding tax. That's the same sort of thing. In number 6, the 985 is 107.75%. And in number 4, the $5,000 is 107% of what you deposit. So it's the same sort of problem. All right. And 7 we talked about already. This is where you divide by 0.8. And number 8, that was the complicated one. Number 9, she wants to have $48,000 cash after paying the government 27% of the amount withdrawn, which is not 27% of 48,000. The 48,000 is the other Well, let's see. What's 100 minus 27? 73. It's the other 73%. So you have to do 48,000 divided by 0.73. Oops, I divided it by 0.3. See, I did that same mistake that I say don't do it. 48,000 divided by 0.73. The 7 didn't click. I didn't click it correctly. That's 65,753 and 42 cents, but it says to the nearest dollar. So the 4 is not big enough to make it 754. So you leave it at 65,753. All right. Let's see if I have. I think this is the right one. Yeah. Number 10. We haven't had one quite like that before, but here's the calculation. 47 wins and 35 losses. What percent will they have won? The winning percentage is the number of games you win divided by the total number of games. So it's wins divided by whatever the wins plus the losses is. And then it says to the nearest 0.1%. And after you change it to a percent, you look 2 digits to the right of the point. It's not big enough to make it 57.4. Number 11 is a very tricky problem. I got it at a grant writing seminar, and the guy who was giving the seminar didn't know how to work the problem. Isn't that sad? So the way I like to teach this is well, $2.5 million is 2,500,000, and there it is. That's $2.5 million. The tricky part of this is the grant requires that the college contribute 2% of the total budget. What the grant guy was doing, the presenter, he was taking 2% of 2,500,000 and adding it on. But that's not what they have to pay 2% of. The total budget is unknown. The 2,500,000 is the rest of it. So if 2% of it is from the college, this must be the other 98%. So what number is this 98% of? Well, let's see. Oh, it would be 2.5 million divided by 98% changed to a decimal is 0.98. And since it's money, you round it to 41 cents because the 8 is big enough. So that's the total budget. And you can get the college's share either by subtracting 2,500,000 from this, or by multiplying this by 0.02. Either way works. To get $51,020.41 because it's money. If I said round it to the nearest dollar, it would just be $20, $51,020. But to the nearest penny, it's got to have the 41 cents there. Now, 12 and 13, you're looking for the winning percentage again, very much like the Spurs game. I'm not going to try to give you too many problems that are repetitious like this. So I'm thinking about having a test that's shorter than 16 problems. Doesn't have to be games. You could have 100 men for every 60 women at the college. And the percent that are women is the number of women, 60 for every 100, divided by the total number of individuals, 60 plus 160, and that's 37.5%. Number 14, you haven't seen that before that I know of. If you add up 5% and 2 is 7, and 20 is 27, and 3 is 30, so all those little things add up to 30%, and 100 minus 30 is 70. So that's what the rest is. The rest is the other 70%, and for that you pay the lot, the labor, and the materials. I like to figure out the labor first. because it's multiplied by so many hours multiplied by so much per hour. So if you do that first, you get 500 times 15. You don't have to. You can just write it down or use a scientific calculator. You could put 12,000 and then you could write down what 500 times 15 is, which is 7,500. But if you do it this way, you could just add $1,200. That's $12,000. That's not right. Oh, it is 12,000. Duh. And then you can add the cost of materials, which is 45,000, and you wind up with 64,500. That doesn't seem right. Let me look at the answers here. I made a mistake. Yes, I did. Oh yeah, I haven't finished it yet. That 64,500 is the other 70%. That's why you have to divide that by 0.7. And when you do that, it gets bigger. It's $92,142.86. But it's money, and you are instructed to round it to the nearest $100. The hundreds place is where the 1 is, and the digit just to the right of 1 is 4, and that is not 5 or more. So you leave it 92,100, and that's where I got that answer from. 15. Another one like pass, fail, wins, and losses. Very much the same as number 13. You have the percent of them passing is 100 divided by the number of people taking. So 100 pass out of 100 plus 125. 100 passes plus 25.1 failures. And that gives you 79.93%, which is, the 3 is not big enough to make the 9. And to make this into 80%, if that 3 were a 5 or more, then it would be, you can't make a 9 into a 10, either one of them. So it's going to be 80.0 if that were 79.95 or 6, 7, 8, 9, that sort of thing. All right. Do you have any burning questions?